In number 11, these two ask us to solve by the method of our choice, and with number 11, I would definitely solve by substitution, because if we look at the first equation is already solved for y. It's telling us that y equals the negative 2x plus 6. So I'm going to plug that into the second equation. So I've got 3x minus 2y equals 16, but instead of y, I'm going to plug in what y is equal to, which is the negative 2x plus 6. And now I need to solve this. I need to distribute the negative 2, and keep in mind that it is a negative 2. This sign tags along for the ride. So that's going to be a 3x plus 4x minus 12 equals a 16. I can go ahead and combine like terms. The 3x and the 4x give me a 7x minus 12 equals 16. I add the 12 to each side, which gives me a 7x equals a 28. And then the last thing I would do here is divide each side by the 7. So I divide each side by the 7. That gives me an x equals 4. But I'm not finished yet. I still have to plug that in. I plug it into this first equation, y equals a negative 2x plus 6. But instead of the x, I plug in what x is equal to, which is the 4. So that's a y equals a negative 8 plus 6, which is a negative 2. So once again, it's the ordered pair 4, negative 2. And that's it. For number 12, method of my choice is going to be elimination here. And this is set up perfectly for elimination because it's already in standard form. Everything's lined up. And if we look, the y's already have additive inverses, so all I have to do is add these together. That's going to give me a 5x equals a negative 4. Which excites me because I know I'm going to have a fraction now. Awesome. So I get x equals a negative 4/5. I'm not finished yet. I still have to plug this in for x and simplify. I'm going to take the second equation this time. So I've got 3x plus 2y equals 1, where x is a negative 4/5, so negative 4/5. So I multiply, and keep this in mind if I need to take this off to the side. It's 3/1 times a negative 4. My board decided to stop working. Oh, there it is. Times a negative 4/5. And when I do that, I multiply straight across. It's a negative 12/5. Okay, so I get a negative 12/5 plus 2y equals 1. And if you're worried about adding the 12/5 to each side, worried about dealing with fractions, remember, we can eliminate the fractions by multiplying through by the common denominator. So multiply each side of this equation by 5. When I distribute the 5, when I do 5 times the negative 12/5, the 5 cancel, just gives me a negative 12. And that's the point. That's why I'm doing this. 5 times the 2 gives me a plus 10y equals 5. And now this should be pretty simple, pretty easy to solve. I've got to add the 12 to each side. So I get 10y equals 17. And then the last thing I have to do here is divide each side by the 10. So I divide each side by the 10, and I'm just going to leave that as an improper fraction as 17/10. So once again, my ordered pair here would be a negative 5/4, comma 17/10. And that's it. Number 7 is the tricky one. Let me fix that. There we go. In number 7, we have to solve by all 3 methods and then decide which one is the best. The first thing I'm going to do is graphing. In order to do graphing, I have to make sure these are in slope-intercept form. The first one is not, so I'm going to have to change it to slope-intercept form. Let me reselect my pen. So if I've got a negative x plus 1/2 y equals a negative 1, I'm going to have to add the x to each side. So I get 1/2 y equals an x minus 1. And now I have to multiply each side by 2. That's how I get rid of the 1/2. So I multiply each side by 2. So I get y equals. Over here I have to distribute the 2. So I get a 2x minus 2. So now each of these is in slope-intercept form. The first one has a y-intercept of 3 and a slope of negative 2. It's down 2/1. And again, I want to be as accurate as possible with this. The second one has a y-intercept of negative 2 and a slope of 2. So I go up 2/1, up 2/1, up 2/1. And because I was careful And because I was as accurate as I could be with this, I can tell now that where these intersect is not on a nice, neat, even point. It's on a fraction. Okay, so my answer here for graphing is whatever that fraction might be. It looks like it might be like 1 1/4 and maybe 1/2, but I can't be 100% sure. So I'm going to put a question mark there for now and see if substitution and elimination confirm what I'm believing here. I'll jump over to elimination next. For elimination, I just need to make sure everything's lined up. Right now, everything's not lined up. The second equation is in a decent format. However, I probably wouldn't even use this because of that 1/2, so I would multiply everything by 2. That's the first thing I would do. So now that second equation is going to be written as a negative 2x plus y equals a negative 2. My first equation I'm going to have to rearrange. Let me bring that guy over here. I got to get everything on the same side, so I'm going to add the 2x to each side. So that's going to give me a 2x plus y equals 3. So now if I were to scoot this guy over underneath my other equation, I can see that everything is lined up. And more so than that, I already have additive inverses in front of the x's. So I'm just going to add these guys together. So when I add them up, it gives me a 2y equals 1. And now I have to divide each side by a 2. So I find out that y equals 1/2. But I'm not done yet. I still have to plug that in. And I can plug it into any one of these equations. I'm going to choose this equation right here. The y equals a negative 2x plus 3. Just because that one's a little bit simpler. So I've got y, which is the 1/2, equals a negative 2x plus 3. Once again, instead of dealing with a fraction, I'm just going to multiply everything by 2. I'm going to get rid of that fraction. 2 times 1/2 gives me a 1. Over here, I distribute the 2. That's a negative 4x plus 6. Now this is an easy equation to solve. I subtract the 6 from each side. That gives me a negative 5 equals a negative 4x. I divide each side by the negative 4. And I find out that x equals a positive 5/4. Okay, the negative divided by a negative is a positive, so it's the ordered pair 5/4, 1/2. And that's it. And that kind of confirms what I saw for graphing, but we're going to do it one more time. I have to do it through substitution. With substitution, let me rewrite these. I've got y equals a negative 2x plus 3 and a negative x plus 1/2 y equals a negative 1. For substitution, the first equation is already solved for y, so I'm going to plug that negative 2x plus 3 in for y in the second equation. So that's going to be a negative x plus 1/2 y equals a negative 1, but instead of y, I'm going to plug in the negative 2x plus 3. So now I have to simplify this. I'm going to distribute the 1/2. So that's going to be a negative x plus a negative x, or sorry, minus x, plus 3/2 equals a negative 1. That's going to give me a negative 2x plus 3/2 equals a negative 1. Once again, instead of dealing with fractions, instead of having to subtract that 3/2 from each side, I'm going to multiply each side by 2. It's going to give me a negative 4x plus. Here, when I multiply, the 2's cancel. It's just a 3 equals a negative 2. Now I can finish solving this for x. I subtract the 3 from each side. That gives me a negative 4x equals a negative 5. I divide each side by the negative 4 and find out that x equals a positive 5/4, which makes sense because that's what I got when I did elimination. I still have to plug this back in for x, so I've got a negative 2x plus 3. Instead of x, I'm going to plug in the 5/4. When I do that, that's going to give me y equals, this is a negative 2 times 5 is a negative 10/4, which is just a negative 5/2. And now from here, I could eliminate the fractions, but since they're already written on the same side, I'm just going to get common denominators. 3 is the same thing as 6 over 2. And really all I did there, if I take it off to the side, I did 3 over 1 times 2 over 2. I'm getting common denominators, a common denominator of 2. Now I have the common denominators. I add the numerators. Denominator stays the same, so y equals a 1/2. So once again, it's the ordered pair 5/4, 1/2. And as far as the explanation of this thing goes, deciding which one was the best method, either elimination or substitution here would be great options. I'm going to say it was substitution because the first equation was already solved for y. First equation already solved for y. I'm gonna do it in caveman speak. First equation already solved y. There we go. Hope you get the gist of that.